Okay, I'm down to my last video for tonight. For number 20, I am given a twice differentiable function f. So this is the original function, but I can tell what's going on with my f prime and my f double prime from here. So they wanted us to find the values of, if not the values, the signs of f of 2, f prime of 2, and f double prime of 2. F of 2 is easy to find. At x equals 2, the y value is located in the x-axis. So that's going to be 0. And then when I say f prime of 2, that's telling me what's going on with the original function. Is the original function increasing or decreasing at x equals 2? Obviously, the graph is decreasing at x equals 2. That means the sign of our first derivative is going to be negative. And then for second derivative of f at 2, we wanted to look at the concavity of the graph. And in this case, the graph is concave up. If the graph is concave up at x equals 2, then that means that the second derivative at 2 is positive. What does concave up look like? Concave up looks like this or like this. Okay, concave down looks like this. It turns it's open upwards for concave up. All right, so the choices look like we're arranging our values from least to greatest, and the least will be the first derivative, followed by, so that the least will be the negative, followed by the 0, and then the second derivative. And our answer is around letter C. Okay, that was easy. All right, so for 21, we are given the original function, and we want to find out where is the dy over dx greater than 0. What does this mean? Dy over dx greater than 0 means the first derivative is positive. It also means that our graph is increasing there. The d squared y over dx squared being positive tells me my second derivative is greater than 0. It tells me my y is concave up there. Okay, I can eliminate choices A and D because they are obviously decreasing there. So I have either B or C. They're both increasing, but when I take a look at the shape of the curve, letter B looks like concave up, or letter B is definitely concave up, and letter C is concave down. There's a point of inflection somewhere between B and C. And that is our answer. Question number 22 is a free response question, and we are given with an f prime graph, the derivative of function f, for the closed interval -4 to 7. F prime has horizontal tangent lines at -1, +3, and +5. That information will come handy later on, I think, in question letter C. Okay, for the first question, we want to find all values of x, so we have to dictate which x's. Between -4 to 7, at which f attains a relative minimum. So since this is our f prime graph, the zeros of the f prime are where our extremas will be. So let's identify our zeros. My first 0 is at -2, +1, and +5. But let's take a look at the signs of f prime at these x's. At x equals -2, f prime changes from positive to negative. At +1, it's from negative to positive. And at +5, the sign stayed positive. So I can already tell what my relative minimum is. How do you justify? I'll justify it by saying f prime is equal to 0. Let's identify the zeros. At x equals -2, +1, and 5. And I'm going to describe where the relative minimum is. F attains a relative minimum at x equals +1 And our justification will be the signs of f prime, because f prime changes from negative to positive at these x. Okay. And that is it. It just has to be short and sweet. You don't have to write a lot of justification here. Okay, let's take a look at question letter B. Question letter B is the same, but we're looking for the maximum. And we've identified it from the previous slide. The maximum is at x equals negative 2 because f prime changes from positive to negative. So I'll just say the same thing. F has a relative maximum at x equals negative 2 because, and if you're given an f prime, you should use that as your reasoning, because f prime changes from positive to negative here, period. All right, letter B was easy. There's so many questions I can ask from this free response question. I can ask where your function f is increasing given an f prime. And it's easy to identify any interval above the x-axis. That is where my f will be increasing. So from negative 4 to negative 2, from 1 to 5, or 1 to 7 actually, f prime is greater than 0 there, therefore f is increasing there. And then f will be decreasing from negative 2 to 1 because f prime is negative there. I can even ask concavity. F is concave. Let's see what the question letter C is. F is increasing. That's easy. All right, so let's say if it's asking for concavity. F is concave, or points of inflection. F has points of inflection at negative 1, at positive 3, and at positive 5. And your reasoning will be about f prime, changing from decreasing to increasing, or vice versa. That's it. All right, let's answer letter C. Write all subintervals for which the graph of f is increasing. And I think I mentioned that earlier. If you are given with an f prime graph, look at what intervals the f prime graph is above the x-axis. So I'm going to write my answer here because I don't have space. F is increasing in the subintervals, or just intervals, or you can just go ahead and write the intervals. Negative 4 to negative 2 and 1 to 7. And our reasoning is f prime is greater than 0 here. Period. Okay, that's our answer for letter C. Again, for points of inflection, I will identify where f prime has a max or min. And my reasoning will be f has points of inflection at x equals negative 1, 3, and 5 because f prime changes from decreasing to increasing, or vice versa. Concave up. Where is f concave up? F is concave up when f prime is increasing, and that will be from negative 1 to 3, 5 to 7. Where is f concave down? F is concave down when f prime is decreasing, and that is from negative 4 to negative 1, 3 to 5. And sometimes they ask questions about where is the graph concave up